What's up, guys? Welcome back to the channel. Today in this video we'll be doing this question paper that you see here. As you can see, this is National Certificate Mathematics N4, and this question paper was actually written on the 30th July 2025, and it took 3 hours to be written. So on this particular video we'll be focusing on question 3. If you haven't watched question 2 and question 1, I will leave a link on the description that contains those two questions, and also the very same playlist will pop up on the top right of this video that you're watching at the moment. So before we start though, the QR code that you see on the right is the QR code for the WhatsApp channel that we have. You can join that WhatsApp channel so that you can able to share some information based on mathematics and the links when you do the live. Since we'll be focusing on question 3, I will leave a timestamp for each and every question that is based on question 3, just in case you don't want to watch question 3 in a sequence order. Without wasting any time, guys, let's look at question 3. Here is our question 3 here. It consists of 4 questions, which is question 3.1, 3.2, 3.3, and 3.4. So we're going to start with this one here, which is 3.1. We're going to copy this question, we're going to paste it where there is space, and then we're going to solve it. So let's solve 3.1. All right, guys, let's look at 3.1 and let's read the question in order for us to solve this. So the question goes like this: determine the value of x if 3 sine squared x plus 2 sine x multiplied by cos x is equaling to 4 cos x plus 6 sine x. So you're also given the domain here where x supposed to be between 0 and 360 degrees. So basically here, guys, we are solving for x. So I'm gonna rewrite this question so that you can able to solve for x. 3 sine squared x plus 2 sine x multiplied by cos x. All this is equaling to 4 cos x plus 6 sine x. Now, they say our x must be between 0 degrees to 360 degrees. So this here, guys, it's our domain. Now, guys, in order for you to solve this question here, you need to do some grouping. There are many ways of solving this question, but the best way that I can solve it is to do some grouping. So what I'm going to do here, I'm going to group the trigonometric ratios that has cos together and the ones that has sines together. So what I'm going to do, I'm going to take this 2 sine x cos x to the right hand side, and then I'm going to take this 6 sine x to the left hand side. So let's do it. Right, so we're going to have 3 sine squared x minus 6 sine x. So I took the 6 sine x to the left hand side, and then we say equaling to 4 cos x, and then we're going to have minus 2 sine x multiplied by cos x. There we go. Then from here we take out the common factor from this one. So if you take out the common factor here, guys, it's 3 and sine x. There we go. So if you take out 3 and sine x, you'll be left here with sine x minus 2. There we go. And then we move to the other one. Here we're also going to take out the common factor. We're going to take out first 2 and then cos as well, cos x. Now if we take out this one here, we're going to be left with 2 minus sine x. There we go. As you can see, let's look at our brackets there. These brackets, they both contain 2 and sine, but one of the bracket, the 2, it's negative, and on the other one, the sine is negative. So you need to manipulate one of the 2 there. Let's write the one on the left as it is. We have 3 sine x sine x minus 2 inside the bracket. And if we multiply by negative on the right hand side, when I have negative 2 cos x, right? And then what you have inside the bracket, Sign is going to be positive, and then 2 is going to be negative. There we go. Now, as you can see, we have sine x minus 2 and sine x minus 2 on both sides. So we can divide by sine x minus 2 both sides. So we divide by sine x minus 2 both sides, sine x minus 2. As you can see, this sine x and that sine x and that sine x and that sine x, they're gonna give you 1. So let's create a space a bit, guys, so that we can solve this. Right, on the left hand side, we'll be left with 3 sine x. On the right hand side, we're gonna be left with negative 2 cos x. There we go. And then from here, guys, we can divide by sine x throughout, or cos x. Let's divide by cos x throughout, guys. So if we divide by cos x throughout there, so we're gonna be having 3. What is sine x over cos? This is the same as tan. We call this the quotient identity. So please do not forget that one. So we can write 3 tan there, guys. Let's write 3 tan x. There we go. And then here we're gonna be left with, remember, cos divided by cos, we're gonna be left with negative 2. We can also divide by 3 both sides. So if we divide by 3 both sides, we have tan x is equaling to negative 2 over 3, because that 3 and that 3, they're going to give us 1 multiplied by tan. So on the left hand side, we're left with tan. On the right hand side, we're going to be left with negative 2 over 3. Now that we have this, we can able now to calculate our x. So let's look at the answer there. As you can see, tan, it's negative 2 over 3. Guys, this means that our x is going to be at the quadrant where tan is negative. So if you still remember the cast diagram, that tan, it's negative on the 4th quadrant and the 2nd quadrant. On the 3rd and the 1st, tan is positive. So first of all, we need to find the reference angle, right? Reference x. So if you find the reference angle, guys, we do not include the negative part of that 2 there, right? So what you're going to do, guys, we're gonna do the following. You're gonna say x is equaling to arc tan. So instead of writing the negative, remember we are looking for the reference. The negative, you're not going to include it, so it's going to be 2 over 3. So this here, the reference angle, is going to give us what here? This is going to give us a 33.7 degrees. This here, guys, is a reference angle, right? Reference x. Now, in order for us to find those axes where tan is negative, we need to remember how we represent the 2nd quadrant and the 4th quadrant. Remember, this is how we represent the 2nd quadrant. It's 180 minus x, right? And then the 4th quadrant is 360 minus x. So this x here is our ref, guys. It's going to be our ref. There we go. So our x is going to be 180 minus 33.7. So this is the first one there. So this is going to give us 146.31. There we go. So this is going to be our first one on the 2nd quadrant. On the 3rd quadrant, we know that we're going to have x is equaling to 360 minus 33.7. So this here is going to give us 326.3 degrees. So this here is another x. So guys, these ones here, this is our x. Remember, our domain says x should be between 0 and 360. As you can see, these here are the values. If you want to check if this is correct for the x values, you can substitute this on the original equation. You can write tan, let me just write it here. You can write tan 146.31 is supposed to give you negative 2 over 3, or the decimal answer that is equivalent to this, guys, right? Again, if you want to check the other one, you can write tan 326.3. It should give you negative 2 over 3. Guys, this is how you're supposed to do this one. Just in case you didn't manage or you didn't understand this one, You can always, guys, go to the point where you got lost, and if that doesn't help, you can leave a comment on the comment section. But really, this was not that difficult, because all you needed to do here, guys, was to simplify until you come to this point where tan is equaling to -2/3. From here, then you solve for x, right? So I hope you guys managed to understand this. If this helps you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. You can also support the channel by hitting the super thanks button, but if you can't do that, a like and a comment will be highly appreciated. Well, guys, we are done with 3.1. Let's go and do 3.2. All right, guys, let's look at 3.2. Now, here's our 3.2 here, guys. Again, I'm going to copy this 3.2, paste it where there is a space, and then we're going to solve it. All right, here is 3.2. Now, let's read the question and let's solve it. The question goes like this: if tan x is equaling to 5/12 and x is an acute angle, determine cos 2x without using a calculator. So a calculator is not required here, guys. So in order for you to do this one, my good people, you need to understand that you have your x as an acute angle. It means wherever this is, this part here is actually happening on the first quadrant. Remember, on the first quadrant, guys, all the angles that belong there are acute angle. So we know that tan is y/x. So we can say here, let me just highlight very quickly. We can say 5 is y and then x is 12. So you can say y is equaling to 5 and then x is equaling to 12. In order for us to use or to calculate double angle identity, we need to find our r, or our hypotenuse. So we know that hypotenuse is the same as r squared is equaling to x squared plus y squared. So we square root both sides, guys. If we square root here, we're gonna be left with r, and there we're gonna have x squared. Remember, x squared here is 12 squared, right? Y squared here is 5 squared. R is gonna be 13. So from here, we can able to use this information that is given to us. Remember, they say we must determine cos 2x. Guys, there are many ways that you can do this one. In fact, there are 3 ways. First of all, you have to change this cos 2x into one of the identities of cos 2x. So cos 2x, it has 3 identities. It's a double angle identity for cos, guys. So I'm gonna go with this one where we have cos squared x minus sine squared x, right? This one is easier because we just square the two, but you can use the other two if you want to. You'll get the same answer, right? So let's substitute. Remember, cos, it's x over r. So what is our x here? Is 12. What is our r? 13. There we go, squared, minus. And then what is our sine? Sine is y over r. So what is our y here? 5. What is our r? 13. So we square this, right? So if you square this, it's gonna give you 144, right? Divide by 169 minus 25 divided by 169. Let's create a little bit of space here, guys. If the denominators are the same, the numerators will subtract here. So the denominator is 169, and then 144 minus 25 is gonna give us 119. So that is your final answer, guys, right? Or you can write it in this manner, 0.704. There we go, guys. But rather leave it in a fraction, guys. This is how you're supposed to do this one. Really, it was not that difficult. Remember, you're not supposed to use a calculator. So this is how you're supposed to do it without using a calculator. Guys, if this video helped you to understand how to solve this question here, do not forget to like, subscribe, share the video, and also comment on the comment section if you have anything to say here. But if you didn't understand, go to the point where you didn't understand, rewatch at that point, and if that doesn't help, comment on the comment section. Guys, you can always support our channel by hitting the super thanks button. If you can do that, you can always like and comment on the comment section. All right, my good people, just in case you don't understand this double angle identity, I'm gonna leave a video where we derive this identity. Right, people, we are done with 3.2. How about we do 3.3? All right, guys, let's look at 3.3. As you can see, here is the question from 3.3. Again, I'm gonna copy this question, paste it where there is space, and then let's solve it, my good people. Let's look at 3.3. Now 3.3, the question, they want us to prove that the left hand side, which is this one here, is equaling to the right hand side, which is that one there. Guys, the best way of doing this one, guys, is to always select the most complicated side. So we're just gonna select the left hand side because it's the one that is complicated. So I'm gonna write left hand side. Let's rewrite it. So when we rewrite it, we have cos squared theta minus cos theta minus sine squared theta, right? All this is divided by 2 sine theta multiplied by cos theta plus sine theta. There we go. So the best thing that you can do here, guys, is to change one of the square trigonometric ratio there. Since we have a lot of cos's on the numerator, I will change sine to be 1 minus cos squared theta. Remember from this identity here, remember cos squared theta plus sine squared theta is equaling to 1. If we make sine subject to the formula, sine squared theta, we're going to have 1 minus cos square theta. So instead of writing this sine squared theta, we're going to write 1 minus cos squared theta. So let's continue. Right. So on the numerator on top there, we're just going to continue write cos squared theta minus cos theta minus, instead of writing sine squared theta, we're going to write 1 minus cos squared theta. Right. On the denominator there, guys, we take out the common factor. As you can see, we have two terms there. So the common factor there, it's sine. If you can see, guys, if we take out sine theta, we'll be left with 2 cos theta plus 1. There we go. And then we continue further, guys. Let's just continue here. Now if we continue, we have to remove the brackets. So we're gonna write cos squared theta on the numerator minus cos theta. If we multiply by negative to remove the bracket, we will be left with negative 1 plus cos squared theta. Right. Divide by. Still, guys, we still have our sine theta on the denominator multiplied by 2 cos theta plus 1. We still have that on the denominator. So I'm going to continue on top here, guys, so that we save space. Right, let me continue here. If you continue there, let's look at the numerator. Let's look at the like terms here. We have cos squared theta and another cos squared theta. So they're going to add each other. They're going to give you 2 cos squared theta. Do you guys see? Minus cos theta minus 1. Do you guys see? There we go. And then we divide them. On the denominator, nothing changes, guys. We still have sine theta multiplied by 2 cos theta plus 1. There we go. But if you can look at the numerator there, guys, we have the trinomial. It means we can factorize the numerator. Now, if we have 2 brackets on the numerator, we have 2 cos theta and cos theta. Guys, 2 cos theta multiplied by cos theta, they're going to give you 2 cos squared theta, right? So those are the factors of 2 cos squared theta. Then the factors of negative 1, it's supposed to be negative 1 and positive 1. So first we're going to write 1 and 1 there. But since we have negative in the middle there, it means this one there is going to be negative and that one is going to be positive. Right, so this is how you factorize, my good people. So we divide them. So as we divide, we still have sine theta multiplied by 2 cos theta plus 1. Guys, if you can look at your denominator and the numerator, we have on the denominator 2 cos theta plus 1 and another 2 cos theta plus 1 there. So what are we left with there? We are left with, let's check the numerator, guys. Change the color. The numerator, we are left with cos theta minus 1. And then both of these, they're divided by sine theta, right? Right. Now you can separate this. Let me just separate them very quickly. You can write it like this: cos theta divided by sine theta minus 1 over sine. There we go. So let's create a little bit of space here, guys. Let's create a space. What is cos over sine? Remember, cos over sine, guys, it's cot theta. Well, 1 over sine, let's just leave it for now. 1 over sine, let's leave it for now. Remember, we're trying to make the left hand side to be equaling to the right hand side. If you go back there, for 1 over sine, we already proved it. Negative 1 over sine. It's time for us to prove 1 over tan. But it's already proven, guys. What is cot, by the way? Cot, if you still remember the reciprocal or the inverses, cot is 1 over tan. There we go. So we can rewrite this as 1 over tan theta minus 1 over sine theta. You can say, therefore, left hand side is equaling to right hand side. Right, let's look at our question there. Let me zoom down, guys, but I think you can able to see that. Zoom down again. There we go. There we go, guys. There we go. Let me highlight it there. There we go, guys. Let me highlight it there. You guys see this here, which is our right hand side? It's 1 over tan theta minus 1 over sine theta. It's the same as our answer there, 1 over tan theta minus 1 over sine theta, which is left hand side is equaling to right hand side. Right, people? So this is how you're supposed to do this one. I hope you manage to understand how I've done this one. There are many ways of doing this question, guys. So this is one of the ways I could think of. But make sure when you solve this type of a problem, you try to deal with identities when you see identities. So guys, if this video helped you to understand how to solve such a problem, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed to the channel. But if you got confused somewhere, you can always watch at the point where you got lost. And then if that doesn't help, you can leave a comment on the comment section and I'll try to help you to my level best. Guys, you can always donate on our channel by hitting super thanks button. But if you can't do that, a like and a comment will be highly appreciated. Guys, we are done with 3.3. How about you go and do 3.4? Right, guys, we are done with 3.3. Let's look at 3.4, which is the last question of this question 3. So we're going to copy it, paste it where there is space, and we solve it. All right, my good people, let's look at 3.4. Now, 3.4, they want us to derive a formula for 1 over sec 2 theta in terms of sine only. Right, so this question here, guys, the only trick that they have here is 1 over sec. Remember, 1 over sec, guys, cos, right? Made videos on these inverses. I'm gonna leave the link on the description, and also the link is gonna pop up on the top right of this video that you're watching here. Let's rewrite the question and then let's solve it. So first of all, 1 over sec 2 theta, we know that this is equaling to cos 2 theta, right? So you can continue here and rewrite this in this manner. You can say cos theta right, plus theta, right? So cos theta plus theta. Now this becomes your compound identity. So when you do the compound identity, remember for cos it's gonna be cos theta multiplied by cos theta. When we have plus between the thetas, it's gonna be minus here. It's gonna be sine theta multiplied by sine theta, right? So what do we have there, guys? You're gonna have cos squared theta minus sine squared theta, right? Guys, this is a double angle identity. There was no need for you to do the first two steps. If you understand that cos 2 theta is the same as cos squared theta minus sine squared theta, then it's fine. It's a double angle identity, but you can always show this as well. Right, now it's time for us to use the information that is given to us. Remember, they said we should derive it in terms of sine only. So meaning we need to change this cos squared theta in terms of sine. So how are you going to do this, guys? Very, very simple. We go back again to this square identity. If you still remember the square identity here, where we have cos squared theta plus sine squared theta is equaling to 1. So we need to change this in terms of sine. So we have to make cos squared theta subject to the formula. So if we do that, this is going to be 1 minus sine squared theta. So wherever there is cos squared theta, we substitute with 1 minus sine squared theta. So let's do it. So instead of writing cos squared theta, we're going to write 1 minus sine squared theta. Let us not forget we still have sine squared theta there. And then if you look at this, we have negative sine squared theta and negative sine squared theta. They are like terms, so they should give us two of them. So the final answer is going to be 1 minus 2 sine squared theta. There is your final answer, guys. So this, guys, it's basically how to derive the double angle identity. Just in case you don't know how to do that, I made a video explaining actually how to derive this double angle identities for sine and cos. So you can go to the description and click to the link, and also the very same video will pop up on the top right of this video. Guys, we are done with 3.4. I hope this part of the video helped you to understand how to derive the double angle identity. If this video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Guys, if you don't understand, you can always go to the point where you got lost, rewatch it, and if that doesn't help, you can leave a comment, guys. I will answer you to my level best. You can always support our channel as well by hitting the super thanks button, but if you can't do that, a comment and a like and a subscribe will be highly appreciated, guys. We are done with question 3 as a whole, guys. I hope you managed to get this one as well, and I hope you managed to understand as well. So now that we are done with question 3, we'll be doing question 4 very soon. So hit the notification button so that whenever I upload question 4, you will be notified as soon as possible. Thank you very much, guys, for watching. Till next time, cheers.